This is Unit 3. This will be the page 5, and primarily using the calculator. Okay, so in number 11, they are asking us to find the intervals over which f is increasing or decreasing. Now, there's kind of two ways that you can do this. I'll do it kind of the calculus way first, and then both of them are going to involve the calculator, but there's kind of two ways where you can do it. So when you're trying to find intervals of increasing and decreasing, you should be thinking that you want to take the derivative, okay? So when you take the derivative, that's careful, that's a chain rule. The derivative of cosine is negative sine, so it's going to be negative sine of 3x times the derivative of the inside, which is 3. So it'll be negative 3 sine 3x, and then the derivative of this part over here is just a negative x. Okay? So my goal is to take that derivative and find where it equals 0 or where it doesn't exist. I don't need to worry about this one not existing. So I'm just going to take this and 3x, and I'll set it equal to 0. Well, that's where my calculator is going to come in handy, okay? So to figure out where that equals 0, the easiest way to do that is to turn your calculator on, right? Hit y equals, and we're going to type that in. So negative 3 sine 3x. Notice my calculator is in radian mode, and it was a minus x. Perfect. So I would recommend hitting zoom and then maybe trig here. Let's see what that does. There we go. Oh, and keep in mind here that I'm only looking at the interval of negative 1 to 3, so it would probably be a good idea to adjust that window so that I'm not getting all confused with all this stuff. So when I go to my window, if my interval is negative 1, I like to do like negative 1.1, and then for my x max, it'll be 3.1, just so I see a little bit on either side, and then I can graph it. And that'll kind of just tighten up that window so I really can see what I'm looking for. Now, again, I'm trying to figure out where this thing equals 0. So to do that, you're going to be hitting the second key and then the trace, and then you're going to find where it hits 0. Well, the first one's pretty obvious there. You can see that it crosses right at 0, but you can still, if you wanted to, right, figure that out using that. I won't waste the time, but yeah, so it crosses at 0, and it's also going to cross over here. So left, I hit enter, I go to the right of it, and I hit enter twice. This will give me my second critical value there. So again, this yields that x equals 0 and 1.182. And then to get the second, or the last one there, and then I'm going to go to the left of it, hit enter, go to the right of it, hit enter twice, and that last one was 1.870. So those are going to be my 3 critical values that I am then going to put on a sign chart. Okay, so we're going to take this information, and I like to put it in a sign chart. Remember, a sign chart tells you the relationship between the derivative and the original. So here, the derivative, you could see that to the left of 0 it was positive, and then between 0 and down there it was negative. And then up here again it was positive, and then it went to negative. So that tells you that the original was increasing, then decreasing, then increasing, then decreasing. And that's what it's asking me for. So I can conclude that we were increasing on the original was increasing from negative infinity to 0, union from 1.182 approximately, and that was until 1.870. And it was decreasing on the interval 0 to 1.182, and then decreasing again from 1.870 to infinity. Okay? Now, the alternate solution for this, so if this makes sense to you, I would say just kind of skip the next minute or so. But the alternate way that you could have solved this is because you were given your calculator right from the beginning, you could have, instead of even taking the derivative and risking making a mistake, you could have just typed in the original into the y equals here, and I'm going to say 0.5x squared, okay? And you could have graphed that. Now, the difference here is that you have to look for the relationship. We're looking for the intervals over which it's increasing or decreasing. So if you were looking at just this graph, you would be looking for the maximums and minimum points. So you would be concerned with this right here and this peak right there. To find those, you'd hit second, calc, you'd go to choice 3, minimum, and then you'd go a little to the left and a little to the right of that minimum to find it. Notice that it gives you that same 1.18 that we got previously. And to find the other one, you could do second, calc, maximum this time. And I want to go to this peak here, hit enter, and then go to the other side of the peak and hit enter. And again, it gives us that 1.87 number. And again, you could tell right away that at x equals 0, it also has a maximum there. So that's the other way, but I actually prefer the sign chart, and that's what I would recommend that you do it. Okay? Okay, so now, number 12 is the last calculator question, the last one that I'm going to be working through. So it says, for this function, find the intervals where you're concave up or down. So when I see concave up or down, that leads me to believe I'm going to need to use my second derivative test. Okay, so I'm going to take the second derivative. So the first derivative, it's going to be negative 4x cubed plus 3x squared minus 1. And then over here, what am I going to have to do for this? Well, the derivative of e to the x means you recopy it, and then you multiply it by the derivative of the exponent. So let's see. The derivative of the exponent is going to be a negative 2, and I recopy it exactly as I see it. So there's the first derivative. Now, the second derivative. So now I'm just taking the derivative of this line here. This time that'll be negative 12x squared plus 6x. This negative 1 completely goes away. And again, to take the derivative of e to the junk, you recopy it, right? And then you multiply by the derivative of the junk. So if I recopied this, but then multiplied it by a negative 2, it would end up being a positive 4e to the negative 2x. So there's my second derivative. And my goal here is to set that equal to 0. So then I'm going to use my calculator. So I set this equal to 0, and to do that, you just type it in to the y equals of your calculator, and then we're going to find the zeros just like we did in the last problem. So let's see here. So I clear any junk out of there, and I'm typing this in. So negative 12x squared plus 6x plus 4 second e raised to the negative 2x. Okay, I always just kind of look at it at the end to make sure that that's how I want it. And I'm going to hit zoom 6 this time because my window was all messed up from before. So I want to get back to a normal window. And it's just going to take a second to graph it there. And so this only has one critical value because it only crosses the x-axis once. If you need to zoom in, you can. I don't think I need to. So I'm just going to hit second calc. And then I go to the left and to the right of it. And let's see, that's going to be at 0.643 when I round. So I'm just going to note that. So this occurs at x is approximately 0.643. And I can do a sign chart there. Okay, so at 0.643. Well, what can you tell me about it? Well, before it was positive, right? To the left of that number, it's positive. Below that number, it's negative. So that means that the original must have been concave up, right? Because we're talking about my second derivative in the relationship to the function. And after that, it was concave down. So I can conclude that it is concave up on the interval negative infinity all the way to that 0.643 number. And I can also conclude that it is concave down on the interval 0.643 to infinity. Like that. So, because it did switch concavity, I can conclude that there is a POI at 0.643. Now, how do I get the y value for that point of inflection? What I would do is go back to your y equals and type in the original, that negative x raised to the 4th plus x raised to the 3rd minus x plus e to the negative 2x. Oh, that's all messed up. Well, I would type that into the original, type that into your y equals, and then hit second calc value, and then just type in that 0.643 number. If you do that, you should end up with negative 0.272 as your point of inflection. Okay? Alright, I'm just going to quickly walk through that last problem. Okay? So here's the last problem there. Whenever you're given the graph, you need to make sure that you're paying attention to what they're giving you. In this example, they're giving you the derivative. So my suggestion is to turn this graph into a sign chart. Remember, we care about when the derivative is positive or negative. So I was saying that it's positive till about negative 4.5. Then it's negative until you get to 0, when it goes to positive from 0 to 2. And then this didn't quite cross at 5. I think I intended it to cross at 5, so I just kind of said 5-ish. Okay, so that tells me that the original was increasing, decreasing, increasing, decreasing, increasing. Well, that helps me conclude that there must be a max here, and I'm in there, a max here, and then I'm in there. Okay, remember, a point of inflection only occurs when you switch concavity, aka when your derivative switches from increasing to decreasing or decreasing to increasing. Okay, so where does that happen? So you have to look back at the original graph. So this graph is decreasing here, then it starts increasing, which makes this a point of inflection. It's increasing, then decreasing, which makes that another point of inflection. And then it's decreasing to increasing, so there. Those are the values of negative 3, 1, and 4, which is where I got those from there. Okay? So good luck, and on your test for Unit 3.